very confident that it's going to relate to sand ground. So let's look at a flight line here. We're going to zoom in. This is Norfolk. So Highway 20 is up here. We're going to look at this one cross section. It is both for Enra and Lower Elkhorn. So here's that resistivity. Makes sense to you guys? Takes a little bit of work. So we go in there and we start laying out boundaries. And the other thing is we bring up all the test hole information. It's all part of those databases that you get in these reports. And then we start making our hydrogeologic picks. This is not as useful for the general public as this is down here, which is the interpretation. Remember our colors: blue, next to no aquifer; tans are marginal aquifers; yellows, principal aquifers; and over here by Pierce County, you see some of the coarser zones in the principal aquifer. The other thing that's interesting here, you see this orange line right here. That orange line is the contact with the Ogallala Formation, the Quaternary sediments up above. The Ogallala only exists over here on the western end, in this section of the study area. And you notice that this orange line kind of cuts through this blob. Well, we had a lot of discussion with Sue and Katie and others, and we looked at that and we said, we're not buying the CSD, and this is straight from the CSD cross-section. We're not buying this as the correct text. So we spent a little time talking about it. So this line is going to be moved on the CSD cross-section to incorporate a different geometry for what's there, based on the AEM. And the reason is we have plenty of test holes, and if you follow where the Ogallala picks are on the test holes, it makes sense. You add in the AEM, now you've got enough information to understand it more completely as a natural system. The other thing that's on this map, the CSD 1995 water table. As you can see, it flows from west to east. And then all the bedrock units. We're seeing approximately 1,400 feet here. This is the Dakota. And this is something that's out on the horizon for Nebraska. We're seeing more and more that people are looking at the Dakota as a water source. But you may ask, why is it two colors? Well, because in this section of the Dakota, and we don't have hardly any test holes, so it's difficult for us to really characterize it. But what we do know is where it's this light green, it's more resistive, and that makes it fresh water. If you put saline water in this, it's going to look like this. So we know that the water, based on the resistivity values in previous work, it can't be this color if the sandstone is the same. And it's a mix of sandstones and shales. We can't separate them all out. Down here, it could be saline water or shale or whatever. We just don't know. So if you were exploring for water in the Dakota, you'd probably look in this area. So let's do a quick close-up and talk about the impacts that we talked about before, why the variability matters, and why we need to understand these things. This is the creek by the airport. Just fell right out of my brain, I'm sorry. That we flew out of. It's north and east of
Wayne.
Yes, thank you. Too much travel, I think. So the airport's right about here. This is the floodplain. This is the non-aquifer material. Here you have marginal aquifer. Here you have good principal aquifer. You can see it's not very extensive. We've really exaggerated it and blown it up. We have good test hole control, so we understand how this happens. This is a fine example of hydraulic connection to a stream. If you look at this and you go along from where it's principal to marginal, and then it hits basically a no-flow boundary, because this is silts and clays and hills, and then directly underneath it is the Carlisle, which is a no-flow boundary. It's bedrock, it's a shale, no water gets through it. You have this very limited area from the stream that a groundwater model would be effective in predicting depletions, connections to other areas in the groundwater model system. This is the variability that's important to us as groundwater managers and surface water managers, just how big of an area along this stream is affected by pumping or basically base flow, etc. So let's back up a second and look at it in we know this is pretty isolated and there's alluvium along the stream. But how about up here in Pierce County? How do we follow this out? Well, pretty good aquifer, pretty good what? Gets into that marginal aquifer, but it's still hydrologically connected. There's not a boundary condition that you can see. Then you get into principal aquifer again, principal aquifer all the way over here, and then you hit this snow flow. So if you put wells in over here, it's not going to reach out this way. If you have wells over here, it can reach this other direction. So it's the connectivity of the subsurface and how you set up your management areas where the wells are and where they are not. This was the information that the lower Elkhorn was looking for. So let's look at it with all the flight lines. I like this. As a geologist, I look at visualization. I like to see patterns. And so Pierce County's up over in here. This is that area by Wayne. This is the creek that we just talked about, coming down through there. There's that zone. So the important part is when we look at this, glacial cover all the way to right here. And if I was going to draw a management area, I could throw a rope right around this right in here and say this is very different than this area here. Then you look at this, and all of a sudden you can see that that's different also. So this gives you a visual interpretation of some of the management areas that you can work on. And I'm running a little bit long, but this is just a different direction looking at it. The important part is when you make a 3x3 grid, all of a sudden you can start thinking about your management area. So, Google Earth files, these are available as part of the report. You click along the line anywhere and you get the same information, water table, elevation, top to the different formations, etc. So the conclusions are very useful for groundwater management. I'm going to speed up because I just noticed we're a quarter till. The principal aquifer is thicker in the western and southern third of the lower Elkhorn. The quaternary and tertiary act as the principal aquifer in the west. The aquifer, non-aquifer aquifers materials are abundant in the central and east. And the full thickness of the KD is revealed in the AEM survey. So, AEM collected elsewhere in the LENRD. Besides what we showed, here's Clarkson. Here is Oakland, that was one of our first projects. So let's look briefly at the Clarkson survey. These were the planned flight lines for Clarkson. These are the completed ones. You see they're a little wavy and they had to go around houses, towns, etc. What do the results look like? You've already seen it. We were able to map the principal aquifer. Not only that, with the volume, they had 108,000 acre-feet of groundwater in storage. So, that's a pretty valuable number for this area as far as development. So, eastern Nebraska, this is all pretty preliminary. You saw most of it in the previous slides that I gave you, so we're not going to go into great detail on the northern end, and we just don't have a lot interpreted for the southern end, so we'll kind of cruise through this pretty quickly. This is without the 3x3 mile grid. It's not as intuitive. If you look at this, the patterns don't show as distinctly. It's good to know where this information is. It focuses our ability to have future studies and where extra work needs to be done. But I have a difficult time picking out a pretty continuous pattern. The 3x3 mile grid seems to be pretty good for regional management purposes. The close flight lines, like you saw in Clarkson, which are 400 meters apart, that's where you get the detail as far as aquifer storage, etc. So let's kind of go real quick to this spring. We flew 684 miles. There was 11 flights. This is where we flew all the way down into the MAH00009, very close to the Kansas border, was the furthest south. Flights went very well. I will say, working with the NRDs, we were really inventive in our flight line. The pilot was very good, but boy, I'll tell you what, it makes life interesting. So let's look at a couple of simple preliminary resistimities. This is coming through Lincoln to the south. Again, one of the things that's happening here is bedrock is more near the surface the further south you go. On average, about maybe 60 feet of quaternary material on top. A lot of places the rock's outcrop, so I'm not even going to talk about interpretation, except for you know, you can see the variability here. That's the important key to this spot. And then lastly, again, this is that north-south section going south, but whoops, but this is the fun one. Let me back up. For a geologist, it's the fun one. Sorry, folks. There we go. What's wrong with this picture? Dana, what's wrong with that picture? We have an amazing fault right here, and here we have a dropped block in the area. So, and we're talking hundreds of feet of displacement. So this is something that the geoscientists all just jump up and down and go, wow, look at that. We can show you right where the faults are and where they aren't. How does that help me with water resources? If I was in this area of hard rock and little aquifer material, I'd want to go into these crumbled zones along the fault line and see if maybe we could drill into those and see if there's any good water. The other thing is these deep sections. Jesse Corse at CSC went up and observed a hole drilled by Omaha that went 1,000 feet. They got fresh water at a pretty good capacity out of the Ordovician. Pretty amazing. So we're actually seeing some of that stuff that he drilled into. Again, just another example of how things vary. You can tell by the color patterns that things are different. I promise we'll have a report out by June 30th and we'll explain all this stuff as best we can. But the important takeaway here is this is fresh off the press, just a few weeks old, and we're already looking at it and seeing all of these changes. We'll interpret them and get back to you. So that's about all I really want to say about that because it's so many. Lastly, future of AEM. This is something we did in Lower Elkhorn that was part of our work and Sue Lackey's. This was something that we had a test system from Denmark and we flew it on our nickel just to see how well it would work for stream mapping. And this is south and east of the town of Norfolk, so this is the flight line. These sites that you see are sites that Sue did doing the geoprobe and permeability tests. This was part of some of the work that we designed back with fully appropriated basins. And what we did is we mapped electrical conductivity, her estimate of hydraulic conductivity, her lithology log to the AEM section. And this AEM system was very shallow. It saw about maybe 200 feet, 300 feet down at the most. As we flew, we found some paleo channels we didn't know were there. You can see where the aquifer of the Elkhorn River exists. It matches very well with the test holes. So the bottom line is that's the tour for eastern Nebraska. There's a whole lot more to talk about. That's what I have. I'm happy to entertain questions. And a lot of people to thank for this. It's not just XRI.